Okay, so on Notes 8.1 we're going to be using laws of exponents to simplify. So Law 1 states that when you have bases that are the same, so let's go over what a base is. A base is what is directly in front of your exponent. Okay, an exponent is raised to that power. Okay, so notice that on Law 1 the bases are both a's. Since those are the same, your base never changes, so it stays as a. And then when you multiply, you add the exponents. So I would do m plus n. So Law 1, when you multiply, you add exponents. Okay? Law 2 states that if we divide, notice we subtract the exponent. You'll take the top minus the bottom exponent. So when you subtract, and bases are the same, when you divide, you subtract exponents. Okay? Law 3 states that if you have parentheses and an exponent on the outside, you will distribute it to the inside. So I'll distribute it to both of those variables. So I would have a to the m times b to the m. Since a and b are not the same base, we would not be able to add those two m's together. So it's like distributing. We've been multiplying those together because this is like a to the first and b to the first. Okay. Same thing on Law 4, except you were dividing a divided by b. So same thing, we'll distribute that m to both of them. So a to the m over b to the m. And notice it says b cannot equal 0 because we're dealing with a fraction. We can't have a 0 in the denominator. Law 5 states that when we have a to the m and then an exponent on the outside, so n, we will multiply just like on 3 and 4. We'll distribute that outside exponent to the inside and multiply. So when you have a power raised to a power, you multiply the powers. Okay, Law 6, any base, no matter if it's a variable or a number, raised to the 0 power will always equal 1. Okay, except a cannot equal 0. So any number other than 0 raised to the 0 power or a variable raised to the 0 power equals 1. All right, we're going to start simplifying each expression that we have. So notice we have parentheses. We need to go over the difference between a coefficient and the base. Okay, notice on this example 3. 3 is a coefficient, okay, because it's in front of the x. Okay, so it's a coefficient, not a base. So what we will have to do is we'll have to distribute that squared to the 3 because it's a coefficient, so 3 squared, and then also distribute it to both of our variables that we have. So remember, when you're distributing that to another exponent, power to a power, you'll multiply the powers. So that would be x to the 4th. This is y to the 1st right now, so that would make it y squared. Anytime you have a base that is a number raised to an exponent, you should be evaluating that. So 3 squared, I can evaluate. I can actually get an answer there. 3 squared, 3 times 3 is 9, x to the 4th, y squared. So there's my answer. Okay, let's look at 2. Now, we talked about a coefficient on number 1. 3 was a coefficient. Negative 2 on number 2 is not a coefficient. Notice that it is directly in front of that squared. If it's directly in front of an exponent, that is called a base. This at the top, number 1 was a coefficient. Bases, you never change. Okay, so this base, negative 2, stays the same because that is a base, not a coefficient. I will distribute that 3 to the 2. When you have a power to a power, you multiply the powers. Just like distributing when you have parentheses and you're dealing with regular numbers on the outside. You'll multiply them together. So that would be to the 6th power, 2 times 3. Notice that our base is a number. We can evaluate this. If you're using the calculator, make sure that you put -2 in parentheses before you raise it to the 6th power. So I'll show you how you could do that if you wanted. So in parentheses, -2. To raise it to any power that you want, you're going to use the caret key, which is below clear. And we're raising it to the 6th power. You should get positive 64. If you did not put -2 in parentheses, notice on the calculator you're going to get a different answer. It should not be a negative answer. Okay, so you have to put parentheses around the negative before you raise it to a power. Okay, so the answer would be 64 there. All right, notice on 3, we are dividing. Look at your 12 and your -4. Those are both coefficients, not bases, because there's not an exponent right after that base. Okay, that's a coefficient. So we're going to go ahead and divide those coefficients. 12 divided by -4 is a -3. Then notice the bases of our exponents on this example are both a's, so they're the same. When you divide and the bases are the same, look back up at the top, your law states that when you divide, you subtract the exponents. So base is going to stay the same, a. 7 minus 3, we get 4. Now, notice that we cannot evaluate this one because we're not doing -3 to the 4th. We're doing a to the 4th, so we can't work that out. So that would be as far as we can go. And that's a 4 there. Okay, so number 4, we have parentheses. We can't combine any terms. Like terms have the same variable and the same exponent. Okay, so what we're going to have to do is use the distributive property. Okay, first thing I'm going to do is I'm going to put a coefficient in front of xy squared. So I'm going to put a 1 there. When I distribute, I'm multiplying. This is all one term. This is all one term. I'm multiplying those two together. So start out by multiplying their coefficients. 1 times 3 is 3. Then I multiply the bases that are the same. This is an x. This is an x squared. When I multiply, I add the exponents. So that would be x cubed. And then notice I have a y squared, but I don't have another y on this term. So I'm going to bring that y squared down. Make sure you don't leave it off. That is all one term. I multiplied this times this to get 3x cubed y squared. Now I'm going to multiply 1xy squared times 2y squared. So start out by multiplying the coefficients. 1 times 2, we get 2. Just bringing that plus sign down. Then I have an x, but notice this term I don't have an x, so I'm just bringing that over. Then I have a y squared times a y squared. I'm multiplying, so when you multiply, you add the exponents. So that would be y to the 4th power. Okay, so from here, that's a 3. From here, you should be looking to see if you have the same variables and the same exponents. You cannot add or subtract unless they look exactly the same. So notice on this first term here, we have an x cubed. Notice on this one, we do not have an x cubed. So those are not the same. So we'll not be able to add unless they look exactly the same. All right, so let's look at 5. Notice that we are raising 2r cubed, s to the 5th. All of that to the 0 power. Remember on the law on the front, law 6, anything to the 0 power is 1. Notice that all of this would be the base of our 0 exponent. So our answer here is just 1. Because we're raising all of that inside parentheses to the 0 power. Okay, number 7. Let's talk about a coefficient and a base. The 4s are not coefficients, they're bases because they're directly in front of your exponent. If I had that example, those 4s would be coefficients because they don't have an exponent right after it. They have an x, okay? So you need to know the difference. On this example, we can multiply those coefficients, but since number 7, those 4s are not coefficients, we do not multiply them. The bases always stay the same. So if you have a base, it stays the same. Since they are the same, 4 and 4, when you multiply, you add the exponents. So I have y plus 2, and I'm going to add the other exponent, so plus 6. We're going to combine like terms on that exponent there, so we should get 4 and then y plus 8. I don't know the value of y, so I won't be able to evaluate that. So 4y plus 8 power. Okay, so number 8. We have 2 different sets of parentheses. So what I would do first is I would evaluate the first one, then evaluate the second one, and then when you get those 2, multiply them together. Okay? So I'm going to distribute this squared on the inside. Remember, you have to distribute it to both of them. If there's not an exponent there, it's a 1. So that would be a, we're doing a power to a power, we're distributing it inside, so we're multiplying a to the 8th over b squared, because 1 times 2. There's my first part. Just going to bring down the multiplication there. Then I'm going to distribute the 3 here. So that's going to be a power to a power multiply. It's just like distributing when you're distributing a whole number. You're multiplying. So a to the 6th, b to the 6th. I'm going to go ahead, since this first one's a fraction, I'm going to go ahead and put this in fraction form, so over 1 here. So let's review when we're multiplying fractions together. We need to multiply the tops, multiply the bottoms. So multiplying the tops here, I can only multiply the a's. So when you multiply, you add the exponents. So that would be a to the 14th power. It doesn't look like 4. And then we have that b. That b is not going to change. It's going to stay as b to the 6th power. So you can only multiply the bases that are the same. Denominators, we're multiplying the bottoms. 1 times b squared, we just get b squared. Alright, so I got rid of the parentheses on the first step. Then I multiplied the 2 fractions together. Now I'm going to look and see if I can simplify any more. So notice we're dividing here. Notice we do have bases that are the same, the b's. When bases are the same, and you're dividing, you subtract the exponents. So my a to the 14th power will stay the same. And I'm going to take the top minus the bottom exponent, so 6 minus 2, which would give us b to the 4th. I can't evaluate that, so that would be my final answer. Okay, now on the next part, we're going to use laws of exponents, so the laws on the front, to solve the following equations. When it says solve, it means you're trying to find the missing variable, okay, or the variable. So in all of these, we have an x. So when we're solving, we're trying to find x. Okay, so notice on number 9, the 3's on the left side, these are both bases. We do not change bases. So I'm going to keep the 3, because that's my base. When you're multiplying, because that's what we're doing here, when you're multiplying and the bases are the same, you add the exponents. So I'm going to do x plus 2. And I'm not going to evaluate 3 to the 8th. I'm going to leave it as is. The reason is because we're trying to find what x equals. So if you notice, since these bases are the same, that means in order for these to be equal, I could set that equation up to find what x needs to be. That one's pretty simple. So x would equal 6. 6 plus 2 gives us 8. Those should be the same. If the bases are the same, the exponent should be the same. So we found our x. We can plug it back into the top. If that's a 6 and I add 6 plus 2, we get 8. So those are equal. So you're using your laws of exponents to solve. So let's look at 10. The 3's on the left side are bases, so it stays as 3. We're dividing, so when we divide, we subtract the exponents. Take the top exponent, x, subtract the bottom exponent, which is 2. I'm going to keep the right side as 3 to the 8th power, because that will help me find x. You can either set up your two exponents equal to each other, or just figure out what minus 2 will give you 8. So x would equal 10. 10 minus 2, you get 8. Alright, last one here. Notice we have parentheses. We need to get rid of that first. This 3 is a base, not a coefficient, so it needs to stay as 3. When we distribute that inside our parentheses, a power to a power, we multiply. So that would be x times 2, which is 2x. Notice this denominator, I don't need to do anything with. I want to keep it as the base of 3. And then keep that right side as 3 to the 8th. Now notice here, we're dividing and the bases are the same. When we divide, we can subtract the exponents. So my base stays as 3, because those are bases. I take the top exponent, 2x, minus the bottom exponent, which is 2. That will equal 3 to the 8th. Once I have that, then I can set my exponents equal to each other in order to find what x would equal. So 2x minus 2 equals 8. So add 2. And you end up with 2x equals 10. So x would equal 5. And then you can plug that back in up at the top. If this was a 5 and I multiply those, I would get 10. And then 10 minus 2, when you subtract, you get 8. So you can plug those back in. So that's using the laws of exponents to simplify. We will talk about another law tomorrow. We are looking at 8.2.